Every year, Americans use over 100 billion plastic bags. That's more than 300 bags for every single person in the country. But have you ever wondered, where do all those bags go once they've been used? Do they end up choking landfills and oceans forever? Not anymore. Across the United States, supergiant recycling plants are taking these flimsy single-use plastics and turning them into something new. Packaging, pallets, decking, and even brand new bags. Today, we're going inside one of these incredible facilities to witness how billions of bags are given a second life. Before we begin, don't forget to subscribe to the channel, because we bring you the most mind-blowing processes happening inside the world's biggest factories. Plastic bags, as we know them, were first invented in the early 1960s. By Swedish engineer Sten Gustaf Thulin, who designed the now iconic lightweight polyethylene bag with a simple fold and seal design. By the 1970s, supermarkets across Europe and the US adopted these bags because they were cheap, waterproof, and more durable than paper bags. By the mid-1980s, plastic bags had completely overtaken paper in American grocery stores. But what started as a convenience soon became an environmental crisis. These thin bags were used once, but lasted hundreds of years in landfills. By the 1990s, billions of bags were littering streets, clogging waterways, and even ending up in the oceans. In fact, researchers discovered that plastic bags were a major contributor to the infamous Great Pacific Garbage Patch, a floating island of waste twice the size of Texas. Recycling plastic bags wasn't easy. Early municipal recycling programs couldn't handle them, since the thin film would jam machines. For years, most plastic bags went straight to landfills. But in the early 2000s, major retailers began experimenting with in-store collection systems, and specialized recycling plants were developed to process film plastics separately. Today, companies in the US and around the world run supergiant recycling facilities dedicated to this task. Instead of treating bags as worthless trash, they are now seen as a valuable resource. These innovations not only prevent pollution, but also support a booming industry that transforms billions of bags into new packaging, decking materials, and industrial products. A far cry from their disposable beginnings. The journey begins long before the recycling plant. Plastic bags can't go into regular curbside bins because they clog sorting machines. Instead, major retailers like Walmart, Target, and Kroger provide special collection bins at store entrances. Shoppers return their clean, dry bags here, and trucks carry them to centralized recycling hubs. At the plant, the bags are dumped into huge receiving silos. Conveyor belts carry them to sorting stations where contaminants like paper, receipts, or food waste are removed. It might sound simple, but this stage is critical. Any leftover contamination can ruin an entire batch. After sorting, the bags are compacted into massive bales, each weighing up to 1,200 pounds. Those bales are then fed into industrial shredders, reducing the thin plastic into small flakes. This not only makes the material easier to handle, but also prepares it for washing. The shredded flakes go through a series of washing tanks. Imagine giant bubbling pools of water where plastic spins and floats. Light contaminants rise, while heavier particles sink and are filtered out. Special detergents remove dirt, oils, and ink. After multiple rinses, the flakes come out clean and ready for drying. Powerful air dryers blast away the moisture, leaving behind lightweight, pure plastic fragments. Here comes the magical transformation. The clean flakes are fed into extruders, giant machines that heat plastic to nearly 450 degrees Fahrenheit, 230 degrees Celsius. Inside, the flakes melt into a thick, gooey stream. The molten plastic is then pushed through filters that catch any remaining impurities. After filtering, it's forced through tiny holes to form long strands of plastic spaghetti. These strands are cooled in water baths, chopped into uniform pellets, and dried. These recycled plastic pellets are the gold standard of the process. They are lightweight, versatile, and can be melted again to make new products. Each ton of pellets represents thousands of bags saved from the landfill. So, what happens to these pellets? They're shipped out to manufacturers across America. Some pellets are blown into films and turned back into shopping bags. Others are molded into packaging materials, such as bubble wrap or stretch film. Many are combined with wood fibers to create plastic lumber, which is used in outdoor decking, fences, and benches. In fact, companies like Trex in the US use recycled bags to make durable decking boards that last decades without rotting. Just one 500 square foot deck contains about 140,000 recycled plastic bags. That's an incredible second life for material that once carried groceries. The impact of this process is huge. Recycling 1 ton of plastic bags saves the energy equivalent of 11 barrels of oil. And by turning billions of bags into pellets, America reduces landfill waste, conserves resources, and keeps plastic pollution out of rivers and oceans. Yet challenges remain. Only about 10–15% of plastic bags are recycled in the US today. These plants are pushing for expansion, and why consumer participation, bringing bags back to stores, is absolutely essential. And if you enjoyed this inside look at America's supergiant plastic bag recycling plant, hit that subscribe button, drop us a like, and share this video with your friends. Because together, we can uncover more incredible processes that are changing the way we live, work, and build our future. Thanks to modern technology, there are supergiant recycling plants that give old batteries a second life. They transform waste into raw materials, lithium, cobalt, nickel, lead, and more, that go right back into making new batteries and powering our world again. Today, we'll take you on a mind-blowing journey inside one of these massive recycling facilities. You'll see how millions of tons of old batteries are collected, sorted, shredded, melted, purified, and reborn into new sources of power. So buckle up. This is the incredible story of battery recycling at a supergiant scale. Every year, humanity produces more than 15 million tons of used batteries. Think about that for a moment. With the boom in smartphones, laptops, and especially electric cars, battery demand has skyrocketed, and so has battery waste. The problem? Batteries are not ordinary trash. If dumped in landfills, they leak heavy metals like lead, cadmium, and mercury. These chemicals seep into the ground, contaminating soil and water. Worse, lithium-ion batteries can catch fire and explode when punctured. But there's another side to the story. Batteries are also a gold mine of resources. A single ton of used lithium-ion batteries contains far more cobalt than natural ore mined from the ground. Recycling batteries not only prevents pollution, but also reduces the need for destructive mining. That's why supergiant recycling plants are springing up worldwide. These facilities take mountains of old batteries and transform them into pure reusable metals, closing the loop of the battery life cycle. The journey begins with collection. Used batteries come from everywhere. Consumers dropping AA batteries at recycling bins. industries sending bulk shipments of car and truck batteries. Electric vehicle manufacturers recycling worn-out lithium-ion packs. At the plant's entrance, trucks unload giant crates filled with old batteries. Workers in protective suits and gloves begin the sorting process. Why sort? Because not all batteries are the same. There are alkaline batteries, AA, AAA, household types, lead-acid batteries used in cars and backup power systems, lithium-ion batteries, phones, laptops, EVs, nickel-cadmium and nickel-metal hydride batteries, older electronics, tools. Each type needs a different recycling process. Sorting is done both manually and with machines that scan battery size, shape, and chemical signatures. It's the first step to ensure safety. Mixing lithium batteries with lead-acid ones could cause fires. Once sorted, the batteries move into the mechanical processing area. Here, the magic begins. For alkaline batteries, the process is relatively simple. Machines shred them into tiny pieces. Magnets pull out steel parts, while chemical baths separate zinc and manganese for reuse. For lead-acid car batteries, things get more dramatic. Workers use automated saws to cut them open. The plastic cases are washed and melted into pellets for reuse in new battery casings. The sulfuric acid inside is neutralized into water or converted into sodium sulfate, a compound used in detergents. The lead plates are melted in giant furnaces, purified, and recast into ingots, ready to make new car batteries. But the most fascinating process involves lithium-ion batteries. These are carefully discharged to remove leftover energy to prevent fires. Then they are shredded inside oxygen-free chambers, where sparks can't ignite. The shredded mixture, called black mass, contains cobalt, nickel, lithium, and graphite. This black powder is the treasure chest of the future. Now comes the high-tech part. Extracting pure metals from the black mass. The shredded material is put through hydrometallurgical processes. In giant tanks, acids and solvents dissolve the metals. This step requires extreme precision. A single impurity can ruin a new battery. That's why labs inside the plant constantly test the metals, ensuring they meet 99.9% purity standards. What's amazing is that almost 95% of the materials in a lithium-ion battery can be recovered. That means the same cobalt and lithium used in your old phone might end up powering someone else's electric car tomorrow. With pure metals in hand, the recycling plant hands them over to battery manufacturers. Cobalt and nickel powders are shipped to cathode factories, where they are layered into high-performance battery cells. Lithium carbonate is used to make electrolytes and cathode materials. Lead ingots are recast into brand new car batteries. Even the plastics and steel parts find new life in different industries. The circle is complete. An old battery becomes the raw material for a new one. Instead of mining the earth, recycling plants mine the past. To understand the mind-blowing scale, imagine this. A single supergiant plant can process over 100,000 tons of used batteries every year. That's millions of EV battery packs, or billions of AA batteries. The facility is massive. Sprawling warehouses filled with conveyor belts, shredders, furnaces, and chemical tanks the size of swimming pools. Hundreds of workers operate machinery, while robotic arms handle the most dangerous tasks. The result? Every year, thousands of tons of lithium, cobalt, nickel, and lead are returned to the global supply chain, worth billions of dollars. Battery recycling isn't just about economics, it's about saving the planet. Mining cobalt and lithium often causes deforestation, water pollution, and human rights issues. Recycling reduces the need for new mining, protecting fragile ecosystems. Instead of turning into dangerous waste, old batteries become part of a green, circular economy. If you found this journey fascinating, make sure to hit like, subscribe, and ring the bell icon so you never miss our deep dives into the hidden processes that power our modern lives. Share this video with a friend, because the more people know about recycling, the greener our future will be. Together, let's transform waste into wonder. Used cooking oil, the greasy, messy, brown liquid left after frying French fries or chicken wings, is one of the least glamorous waste products in the world. Yet, in facilities across America and beyond, it is being transformed in a way that is nothing short of astonishing. This is the story of the supergiant oil recycling process. A behind-the-scenes journey into how millions of gallons of waste oil are collected, purified, and reborn as something powerful. Before we dive into today's fascinating story, I've got a quick favor to ask. If you love discovering how everyday things get transformed in ways that blow your mind, make sure to hit that subscribe button and turn on the notification bell. As the trucks roll through the facility gates, they line up at the receiving station. Giant hoses are attached and the contents of the trucks are pumped out. The numbers are staggering. One truck can carry up to 7,000 gallons, and in a single day, a plant may receive dozens of them. Within hours, hundreds of thousands of gallons of used oil are safely stored in massive tanks, each the size of a small building. These tanks are the temporary resting place before the oil begins its transformation. Before anything else, the oil must be screened. At this stage, it is full of visible debris, bits of breading, fries that slipped through the fryer basket, and other solid waste. Large metal strainers catch the biggest pieces, while conveyor systems collect and carry them away. This material, called sludge, may look disgusting, but it doesn't go to waste. Some plants process it into animal feed additives or compost for agriculture. Nothing here is thrown away lightly. Every fraction is considered a resource. The oil that passes the first screening is still dirty. It looks like muddy soup, far from anything you'd ever imagine running in an engine. The next step is centrifugal separation. The oil is fed into enormous centrifuges, machines that spin at thousands of revolutions per minute. The physics here is simple but powerful. Heavier particles are flung outward, while lighter liquid stays in the center. Within seconds, tiny crumbs, charred bits, and grit are forced out of the oil. What comes out looks more uniform, less cloudy, and already much cleaner than before. By the end of this step, the oil has been stripped of most of its solid impurities, but the oil still holds a hidden problem. Water. Used cooking oil often contains 5 to 10% water, either from the food that was fried in it or from condensation. Water is dangerous in the recycling process. It reduces efficiency and can damage machinery if left inside. To solve this, the oil is gently heated in massive dehydration tanks. As the temperature rises, water separates and either settles at the bottom or evaporates into steam. What's left is a golden liquid that looks surprisingly pure compared to the black sludge that first arrived at the plant. At this point, you can almost imagine it being usable. But to turn it into fuel, one more giant leap is needed. Now we reach the heart of the process, the transformation of oil into biodiesel. This step is called transesterification, a technical word that hides a simple idea: rearranging molecules so they can burn cleanly as fuel. The dehydrated oil is mixed with alcohol, often methanol, and a chemical catalyst such as sodium hydroxide. The mixture is pumped into giant reactors, some as large as swimming pools, where it is stirred and heated under controlled conditions. During this reaction, the triglycerides in the oil are broken down into methyl esters, the chemical name for biodiesel, and glycerin. After several hours, the reactor produces two distinct products. On top, the lighter biodiesel. At the bottom, the heavier glycerin. The two layers are separated, and each goes on its own journey. The glycerin can be refined into ingredients for soap, cosmetics, or pharmaceuticals.